Forward. Good morning. We're going to look at the lesson cycle for 0-3 factoring polynomials. Right here I have up the bell ringer and you can get working on that. But before I go too far, I want to just show you how you can know what you're responsible for each day. I've made some updates since the first day of school video on PowerSchool Learning, and so that's what I want to go over. So just as a review of how to get to PowerSchool Learning, if you're on your cell phone, you can just go through the Clever app. I'm going to show you from a computer perspective. I'm going to go to clever.com/n, the word INN, /Dallas ISD. So there it is showing up in the browser. When I click that, it's going to ask me to log in. Now, when we log in with Google, anytime it's with Google, you're going to need to click your ID number at dallasisd.org. So it would come in something like this form for you. Your ID number at dallasisd.org. Now I have a username more than just an ID number, so mine's going to look like my username be Voorhees at dallasisd.org. When I log in, I should see all these apps. And when we spent the first day of school making sure we favorited the correct ones, and so from here, we are going to choose PowerSchool. So when I click PowerSchool here, and now yours will look a little different than mine. And so on yours, you'll see like a parent login, and then on the top right, you'll see a student sign in. We're going to choose the student sign in. For me, I'm just going to choose my teacher one. And now from here, you're going to need to type in just your ID number. So that should be just your ID number. Do not on this page, your first page, do not type in the at dallasisd.org part. It's just your ID number, and the password is DISD $2022. So that's what you're going to do here. So there's my username, which for you is an ID number, and you sign in. Now here, if yours will look a little bit different. You'll see your classes, just like these are my classes listed out by period. You'll see your classes, but then it'll be grade book over here. For me, it's attendance, but that doesn't matter to you. What we're going to be looking at is on this blue ribbon all the way at the top, on the top right, you're looking at that first button. That's the applications button. That's what's going to take us to PowerSchool Learning. Now, something I would recommend for you today is well, again, you can sign in with Google here. Once your page loads up, so with Google, it's going to be ID number at dallasisd.org. I know it's confusing, but whenever it's Google, it has the at dallasisd.org. If it's that resources page, it's just your username. So I'm going back, I'm going to choose my login. Once you're here, I had students talk about this yesterday. They recommended bookmarking this page because you don't have to go through Clever. And so I think that's a great idea. Go ahead and just bookmark this page, save it. That way you can get there really quickly. So you have it bookmarked. I'm going to go to first period here. And now to know what you're responsible for today, I want you to go to chapter 1, lesson assignments, bell ringer /DOLs. And in here, you can see everything you're responsible for. I have the attendance link on the top right, so make sure you take your attendance. And then on the left, there are 4 different things listed. One's the YouTube playlist of me teaching through the whole lesson. The second is optional. It's the blank lesson packet, like if you want to take notes, if you want to just print this off and take notes on it. I'd recommend printing front and back if your printer does that. A different optional is a completed lesson packet. That's everything I worked on written out. So those 2 are optional. What's not optional is this, your Alex 03 assignment and this bell ringers, the DOL and bell ringer exam here. It's kind of like if you were in class, the DOLs that you turn in right before you would leave class period, back when we had traditional classrooms, we were meeting in person. So these are the 2 things you must turn in today, or rather by Thursday of next week, which would be the 17th, to get full credit. So Alex 03 assignment and this exam. Those are your 2 graded work things you have to do right there. So make sure you get those done. Remember, these 2 are optional just to help you out, but you can take notes on a blank piece of paper if you like. Don't forget about your attendance. So each lesson cycle, I'm going to put everything you need in one block here across. So you have your attendance, and there's your lesson. This would be for next class, but for today, you're focusing here. So just to make sure everybody's clear, you're going to have to do the bell ringer and DOL quiz here, and then an Alex assignment. This takes you, if you click it, to Clever. Let me close off some of these tabs. I got a million things open here. And from there, you would go to McGraw-Hill as a reminder. This is to get to Alex. And you click your textbook. We worked through all this yesterday. You're going to be clicking the Alex button there and do it one more time. And there you got Alex. And so from here on Alex, if you've done the tutorial and the initial knowledge check, when you click your 3 horizontal buttons on the left, you'll see an assignments tab come up there. Mine's different because I'm a teacher. I'd have to go to class periods and all that. But for you, you click those 3 horizontal lines, find assignments, and you would see the 0-3 assignment there. That's what you're responsible for today. And so I'm going to stop the recording and let you ask some questions. Okay, what I'm going to do for those who are still engaged here is I'm going to quickly go over some of these problems. If you want to follow along, if you're way ahead by watching the videos, that's great. You can stay ahead, but I'm just going to kind of go over a lot of the stuff here. So we were doing X factoring today, like the videos have said. The idea with X factoring is this, where we look at a trinomial in the form of ax squared, where a is the coefficient of the x squared terms, b is the coefficient for just the x to the first power term, and c is the coefficient that remains by itself. So the way X method works is you're going to multiply whatever the a and c coefficients are, and the b coefficient is going to go down below. You're going to look for 2 numbers rather, and I'm just called them, and then assignment M and N, that are going to multiply to give you whatever the product of A and C are, but that will add to B. So they add here, they multiply up here. So let's get looking at some of these problems. So the first one is given here. 3x squared plus 27x plus 60. Now the first thing you need to do is what we did in the bell ringer, is look for a GCF, this does have a GCF. I see that 3 is a factor that can go in all 3 of these terms. So if I divide out that 3, I'm left with x squared plus 9x plus 20. So I have factored that out. Now, the ax squared plus bx plus c comes from the inside. So this is, we have ax squared plus bx plus c. That means a is 1 in this problem because there's no number or no coefficient in front of the x squared. B is 9 because I have 9 in front of the x. And c is 20. So to get my solution, I multiply a times c for the top of my x, which is 1 times 20. I get 20. And the b value goes down below by itself, so b is 9. 9 goes there. Now I'm looking for 2 numbers to fill in these 2 spots that'll multiply to be 20 and add to be 9. So the only numbers, if I did like a T-chart here, M and N, the only numbers, I like to do the ones that multiply first. I think it's easier. That can multiply and give you 20 would be 1 and 20, 2 and 10, 3 cannot go into 20, and 4 and 5. Now, 5 and 4 would work, but they're basically the same thing as here, and order doesn't matter. So we look which of these numbers could somehow combine to be 9. The answer is 4 and 5. These are our 2 numbers. So I'll put 4 and 5 here. Now this is just a technique to factor. This will factor this part of the trinomial right here. So all this gets factored. Let me move my chart over. I'm going to move it this side so I have some space to write. And the way you factor is you split the a term. So this a term right here, you split its power. And so when you factor, you're going to end up with 2 parentheses. The 3 does not change, so it's going to come out front. That 3 will not change. It goes right there. But you split the a term's power. So it becomes, instead of x squared, the 2 gets divided by 2, and it becomes x to the first on both of these. So it's like x to the first. Notice I have 2 powers. I needed 2, I now have 2. 1 and 1 is 2. So I don't actually have to have the 1 there, so I'll take that away. And then the 2 side numbers go in. Plus 4, plus 5. Now if you have a coefficient of a that's greater than 1, you need to divide each parenthesis by it. And if 1 simplifies, you go ahead and simplify it. This, since it's 1, I don't actually have to simplify or divide by anything, because dividing by 1 will not change the problem. That doesn't reduce, so I don't do anything there. And since dividing by 1 doesn't reduce here, I don't need it. That means this is my final solution. That's called bottoms up, by the way, right there. Okay, let's try another. So in this problem, my a is 1. There's nothing common, so I can't factor it. My b is 4. My c is negative 12. So I'll draw my x. I have a times c, and b is down here. I know I'm going fast, but that's because I'm assuming you've watched the YouTube videos. So 1 times negative 12 is negative 12. b is 4. So I'm looking for 2 numbers that will multiply to give me negative 12 and add to be 4. I go through the product first and I ignore the negative at the start. I just write out the numbers. It could be 1 and 12. It could be 2 and 6. And it could be 3 and 4. Those are the only numbers that multiply to be 12. So it's one of these sets. Now, which of these sets could somehow combine to be 4 by adding and subtracting? The answer is these 2 terms. I could get the number of 4 by saying 6 minus 2. So my numbers are going to be 6 and minus 2. 6 minus 2 is 4. 6 times negative 2 gives me negative 12, so it works. So now I come back, and like I said before, you split your a term, the power. So I have 2 powers, so when I put it in parentheses, my 2 powers are going to split apart because these will multiply with each other. So I'll have x to the first here and x to the first. That's what the front term is. The back term are these 2 numbers. The 6 is positive, the 2 is negative. Again, since my a is 1, I don't have to simplify. That is my answer right there. That's the answer. Now let's try one more here. I look and I see there's something that's shared all the way across. It's a GCF. So I'm going to take out the GCF. The largest number that goes into all 3 terms is 2. So whenever you take a GCF, that goes in front in a parentheses. So 6 divided by 2 is 3. 8 divided by 2 is 4. 8 divided by 2 is 4 as well. It's negative, so it'll be a negative 4. Now this becomes my A, B, and C. A is 3, B is 4, C is negative 4. A equals 3, B equals 4, C equals negative 4. I'll draw my X. A times C goes in the top. 3 times negative 4 is negative 12. And down below, I get a B of 4. These are the same numbers we had just the last problem. If you remember, we were looking for factors of negative 12 that added up to 4. So this should be the same set. I'll write them out just so you can see it one more time. M and N, the 2 side numbers, that's M and N that go here and here. I forgot to put the B down there. B came, that's where the 4 came from, it's the B. M and N go on the sides. So that's what I'm looking for. I'm looking for these 2 numbers. And I like to do the ones that multiply. I think it's easier. So again, it's 1 and 12, 2 and 6, 3 and 4. And now these, you only have to go till the numbers would meet each other or switch, meaning the M becomes larger. So I can stop. That's all of them. That's all the possible factors get 12. The 2 that'll combine somehow to give you 4 were the 2 and the 6. But it only worked if 2 was negative. So M here is going to be, we can put a negative 2, and N is a 6. It doesn't matter the order here. You can do whichever order you want. Like I could have put the 6 first like I did in the last problem. So to finish this off, the 2 is in the front. It remains in the front. So I put the 2 here. But when I break apart the parentheses, I have to break apart this one's power. So it becomes, instead of 3x squared, it becomes a 3x and a 3x. I break apart the power, and then I put the 2 side numbers. Minus 2 plus 6. Okay, this is the first time we've had a problem where a is larger than 1. A is greater than 1. Whenever a is greater than 1, you need to divide both parentheses by that 3. If the parentheses reduces, you reduce it. If it doesn't reduce, you do not divide. This is called bottoms up technique. So when I look at this first parenthesis, 3 can go into this 3, but it cannot go into 2. Since that cannot reduce, I do not divide this parenthesis by 3. But over here, 3 can divide by 3, and 3 can divide into 6. So I will divide this one to simplify to get the correct answer. So my correct answer will be 2 times 3x minus 2 times x plus 2. This right here is my solution. Now, why did I end up dividing here? Technically, you can always divide, but the shortcut is if it's a 1, if a is 1, you don't have to do that because dividing by 1 does not change the problem. Here, a is bigger than 1, so I must divide by 3 all the way across. You only simplify if the entire factor can be divided by that number. Since this could not be divided by 3, I do not simplify there. That's the bottoms up technique. It just kind of means you only divide where you need to divide. That's my solution here. Here would be your first DOL, and so this is what you'll do on PowerSchool Learning. I'm going to continue on with this problem here. So again, I'm going to label it out. There's nothing that goes into all 3s. There's no GCF. There's no GCF, but I have an A value of 2, a B value of -5, a C value of -7. So I draw my X. I'll do A times C up here. 2 times -7 is -14. And my B value is -5. That's my B. So now I'm looking for the terms of N and N. So if I made my chart to figure out my factors, I'm looking for what are the factors of 14? Well, that's 1 and 14, 2 and 7, 3 does not go into 14, 4 does not go into 14, 5 does not go, no, I think that's it. These are the only 2. Which two set, or out of which set could I get a -5? Answer is the bottom numbers, that set. I could say 2 minus 7 would give me -5. So these are my numbers. So I'm going to come over here and replace M with 2 and N with -7. I come back up the top. I take my A term and I split the power. So it becomes 2x and 2x. My side numbers are +2 and -7. Since my A is greater than 1, I got to do the simplifying. A is 2, so I need to divide everything by 2. Notice this can be simplified, and this can be simplified, so I'll simplify there. Over here, the 2 can go into 2, but this 2 does not go into 7. Since I can't simplify, that will not change this factor. So my answer would be x plus 1, because 2 divided by 2 is 1. And over here, 2x minus 7. That is my final answer. Again, I'm going really fast. I am recording this, so I will post it. You'll be able to see it later and to look back. Just to continue on, example 5. Here's my A, B, C. 2 cannot go into 7 or 15. There's no GCF here. No GCF. So I can continue straight on. And so here's my X. A times C is 15 times -2 is -30. My b is 7. It's positive. So now I'm going to look for m and n. So I'm looking for the factors of 30. Well, there's 1 and 30. There's 2 and 15. You might be seeing my pattern. I always start with the 1 times the number, and then go to 2. It divides in. So 3 can go into 30 10 times. 4 does not. 5 does 6 times. And I can stop there because now the numbers will switch, and this side will be bigger, and you don't have to go beyond. So as soon as those two numbers become next to each other or equal to each other, you can stop. So I need to find the ones that combine somehow to be 7. 1 and 30 cannot be 7. 2 and 15 cannot be 7. 3 and 10 can. I can get 7 from these two numbers here by saying 10 minus 3. So 10 minus 3. Those are my two numbers. So again, I take my a term and I split the power. So it's 15x and 15x, and then plus 10 and minus 3. Okay, this one, I need to divide by 15, and it appears at first that nothing can go in with all the numbers. It doesn't look like I can do it on either set, but I actually can do something different here. That 15 can be broken apart, and notice there is a number that goes into both 15 and 10. It's the 5. So I can actually divide this parenthesis by 5, and over here, 3 goes into both of these. It has a factor of 3. So again, it's a practice of the greatest common factor that we did on the bell ringer. There's a reason I gave you that bell ringer, and so you can work on this. So notice 5 times 3 is 15. So anytime a is bigger than 1, you will be dividing out by a factor of that a. So here it's this parenthesis will get divided by 5, and so my answer would be 3x plus 2 for the first factor. Second factor, 15 divided by 3 is 5, and 3 divided by 3 is 1. This would be my answer right here. At this stage, you'd have 2 more DOLs. So on PowerSchool Learning, you need to submit a DOL there and submit this DOL. And now some extra examples or trick problems. So number 6, there is a GCF. And so I first factor out the 2. X squared minus 16. Now this one is a trick problem because if you notice, here's my A. This doesn't have an X, so that's my C. That means B equals 0. It's not there. So why is it a trick? Because when you set up your X method, your B, you need to include a 0. I'm missing the X term. So I just put a 0 there. A is 1. C is negative 16. So 1 times negative 16 is negative 16. And so I'm looking for 2 factors that multiply to be negative 16 and add to be 0. So when I write out my chart here, I start with 1 and 16, 2 and 8. 3 does not go in, but 4 does times 4. And I can stop there because now the numbers are equal. Which one of these could somehow combine to be 0? Answer, 4 and 4. I could have 4 minus 4. That gives me 0. And so those are my 2 numbers. 4 minus 4 is 0, and they multiply to be negative 4. So now you take your A term and you split it. Here, A is 1. So I'll have the shortcut here, since I'll just have X and X. A is 1. I don't have to divide any by anything. I just put the 2 numbers, plus 4 and minus 4. That would be my answer on this trick problem. That's called a difference of squares. Whenever you have a 0 for your B, it's basically like square root technique. You take the square root of x, which is x squared, excuse me, square root of x squared is x. You take the square root of 16, 4 and 4. That's how a lot of Algebra 2 teachers teach that when you have a difference of squares. But the X method does always work for you. Let's try this one. Here, I see there's a GCF. 6 does not go into 63, but 3 goes into all these terms. And I don't like having a negative in the front, so I'm actually going to say my GCF is -3. GCF, I'm going to say, is -3. And so divide this by -3, this by -3, this by -3. And so I'm left with 2x. Oh, I'm sorry. I just realized they all have an x term. Let's include that. So I'm left with 2x squared when I take away 1 power there. This becomes negative. 63 divided by 3 is 21. And 2 negatives make a positive. So there's my term. My new a has become 2. My b has become -21. And my c is 10. So factors of 20 that add up to be -21. So we're looking for m and n now. And so the factors of 20 are 1 and 20, 2 and 10, 3 doesn't work, but 4 goes in 5 times. Those are my sets, and I need them somehow to be combined to be 21. I can get 21 from the top. 1 and 20 give me 21 to make them both negative. I get a -21. Look at that. -1 and -20 more gives me -21. So my m is -1. That's -20. This time, my a is greater than 1. So when I split that power, the -3x is still up front, but I should have a 2x minus 1 and a 2x minus 20. And we have to simplify this. Can both of these terms be divided by that? This is since a is greater than 1 here. Can both be divided by 2? No. But can these both be divided by 2? Yes. So I don't do the division there. So that remains. So it'll be -3x, 2x minus 1 over here. I'm left with x minus 10 when I simplify. That's my answer. All right, here, 4 does not go into 37. There's no GCF. So what's tricky this time? Ah, the powers, they're greater. So here we go. We have A, B, and C. So I'm looking for factors of 36. That's the A times C. That add up to be B, -37. In this particular case, it's going to be 1 and 36. I mean, we could keep going. So 1, 36, 2, 18, 3, 12, 4, and 9. 5 doesn't, but then 6 and 6. That's my whole list. The numbers that combine to be 37 are going to be the first ones, 1 and 36. To make them negative, they both need to be negative. So I have a -1 and a -36. Now remember how I've been saying you got to split the power of A? So I'll split this and it becomes 4x squared, because the power of 4 splits and becomes half of that, which is a squared minus 1, and then 4x squared minus 36. You look and you say, okay, since a is greater than 1, I got to divide by that a term of 4. Can the first parenthesis be divided? No. But can the second? Yes. So this one does not get simplified because 4 does not go into 1. But here I can simplify. And so I get 4x squared minus 1 and x squared minus 9. Now I'm going to blow your minds real quick. Since these are squared, you could actually simplify these both again. This is the difference of squares. It's kind of that shortcut I told you earlier. You could X method this, but for the sake of time, I'm just going to use that shortcut I just told you about. If you're missing a b, so this does not have a b, this does not have a b, you can just take the square root of each. So the square root of 4x squared is 2x. Square root of 1 is 1. And so you write it out twice, once with the positive and once with the negative. That right there factors from the first. This would also factor and give you the square root of x squared is x minus 3 and x plus 3. That right there would be the complete solution to number 8. I know it's kind of long and tricky, but there it is. One more is if you had 4 terms. 4 terms, we do what's called grouping. And so again, I'm going to post this video on YouTube. I know I'm going really fast. But you group the first 2, you group the last 2. So what's a GCF in the first 2? They both have 4x squared. If I take away that, I'm left with 2x plus 1, because 4x squared divided by 4x squared is 1. The middle symbol always drops, so I get a negative. And then I ask, what's common here? It looks like it's a 9. So when I divide by negative 9, I get a positive 2x plus 1. As long as these two parentheses match, you're good. Since these match, you would write your answer as the outside the common factors. 4x squared minus 9 is 1 factor. The other factor is what was matching, 2x plus 1. Again, I'm at the same stage as last problem. This is a difference of squares. Since there's a square there, I can keep going on to get rid of the square. There's no b, so I can actually separate this using square root technique and have 2x minus 3 and 2x plus 3. If you don't believe me, do an x method on that. Just remember your b is 0. And you will get the same solution. Over here, that's a x power of 1, so it does not reduce. It's already what's called a linear factor. That right there is your solution. So that's everything you need to know. You can now complete this assignment. There are some ACP problems. You can kind of see this, what it looks like on the ACP. I have videos for that online already, but that's for this lesson complete now.